I'm James Johnson, and you're watching Niagara Pro Tips. Welcome back to this multi-part video on BQL. Hopefully you've watched the other videos with all the details on the syntax. We're going to wrap up talking about some of the keyword functions and just some miscellaneous things that didn't fit into some of the other videos. Right. As far as optimizing your queries go, there's some options that can help with performance, and two of those are the stop keyword and the depth keyword. The stop keyword is used in order to stop the recursion within a branch in the station. Once it finds the component which matches the extent of the query, it will no longer search in that branch. There's also a depth keyword, which is similar to the stop keyword. However, this allows you to specify the depth from the base ord to which the query will recurse through the component tree. This can also be effective in limiting the extent or the depth of which the query is going to be performed from a performance standpoint. We'll take a look at an example of this. So in this case, the query is looking under this location keyword testing in the station, and it's just looking for control points. Taking a look at the keyword testing, we'll see directly underneath the folder itself is a Boolean writable, which in this case gets found by the BQL query. And then there's another child, which is a folder, and it has a child that's a Boolean writable as well, which also gets found by that query. And if I expand the Boolean writable, we'll see that nested under it is another child Boolean writable point. Now, realize this might be an abnormal situation, maybe how things are organized, but trying to demonstrate the functionality. We'll open up the query using the Control L shortcut. And at the end of the query, we can type in the keyword stop. And this is telling it once the BQL engine finds a component in the tree of the type that matches the extent, then stop recursing through that branch. In this case now, the results change, and we don't find the Boolean writable 3 because it is nested below the Boolean writable 2, and once the query engine found that Boolean writable in the branch, it stopped recursing any further down. So we did find writable 1 because that was a child of the keyword testing, and then there's a second branch using folder 1 here under the keyword testing, and it found the Boolean writable 2 component. The other thing that we can do here is use the keyword depth. If we change or assign the keyword depth and set that to 1, we'll see that we only get one result. So a depth of 0 is the base ord itself. A depth of 1 means only tests for the first level children directly below that base ord. If I change the depth here to 2, now our results will show the Boolean writable 2 because it tested at this level, one level below, and then it expanded or went into the tree one level deeper, and in this case that's the depth of 2 below the starting ord, and it found Boolean writable 3. Then if I were to change the depth to 3 in this case, we should see all the results because the query engine is searching 3 child levels deep below the base ord that the query is resolved against. Another function that we can use is the top X function, and this is used to limit the results that are returned. So after the base ord and the extent have been processed to come up with the working set of objects, then the predicate will be used to filter out objects out of that base set, and then the having clause is processed to filter out things based on aggregate functions, and the order by clause has been run to sort the results. The top X is saying that we want to truncate or only show a certain number of the results out of whatever might be left in the results set. And the top X keyword goes just after select and before any projection. Take a look at a couple of examples here. So in this case, using a BQL query, looking at the BACnet network for the base ORD. Can't quite get it all on the one screen. So the query is looking for control points that are named room temp. So the predicate is where name equals room temp. And we want to order the results by out.value in descending order. So you can see that, again, I only have 2 devices actually communicating on my BACnet network in this case, so all the other room temp values are zeros, but I have 2 values here, and they're sorted by the highest value. We only want to see a certain number of those results then. In our BQL statement, just after the keyword select, we can put in the keyword top and then a number indicating how many of those results in this set do we still want to see displayed. Now you can see my result set is truncated or only showing the top 2 items in this case. This is an example of a history query as well, which might be useful to try to find the highest values in a certain period of time or the lowest values perhaps. In this case, you can see that the BQL query is against AHU1 room temp history. And we're looking at the values where the timestamp falls in BQL time.last month's time range. And then we're doing an order by in descending order on the value column. And the top 2 are then indicating what are my 2 highest room temperatures during the last month in the history. These could be very useful with kW or kilowatt hour history values as well as any other history value that you need to check the max min value of. The cell scheme allows you to extract a single value from a table. In this case, the rows and columns are referenced using a 0 index based ordering system. This is different than the order by, which uses a 1 based index. In order to use the cell scheme, you would use a pipe symbol and append the cell scheme to the end of the BQL ORD. The cell scheme itself will be cell colon and then specifying the column and row to extract the cell from. As far as specifying the column, you can use either the column name or the column index number, with the first column being a 0 index. The row can be designated using either the row index number, with the first row being 0, or the keyword last if you're trying to just extract the value from the last row of the designated column in the table. To demonstrate this, I've got a PX view set up. And when we look at this PX view, I actually have the BQL ORD being shown here in a bound label, just to simplify things a little bit. But the result is being displayed in this table then using that BQL ORD. We also have a bound table, and the bound table is using the exact same history ORD, BQL ORD here, trying to find the top 1 timestamp and value from the previous month. Because this is a label, it then displays record table telling me, hey, you've asked me to display a table of information, and that's what a bound table is for, not a label. If I want to extract that specific bit of information out of the table, the query, we can use the cell scheme. Stretch this out where we can see it. And you'll notice that it's the same query here, but at the end of it, I put a pipe, cell colon, and then 1 being the column, the second column, because it's a zero base index. So I want the value column, and it could be the name, like value in this case, instead of the index number. And then the row is 0 being the first row. So this extracts the 81.7 degree Fahrenheit value out of the table and displays that in the bound label in that case. All right. We also have an option to display interval values or delta values when historical values are totalized, meaning ever increasing. And the delta syntax is used as a question mark and a parameter delta equals true. We talked about in the predicate section about using the time range or the period syntax rather with the question mark after the history ID when it's specified in the base ord. So this is a way that we can tell the engine to return interval values instead of totalized values. Just to clarify, if I look at a web chart, for example, with this history, which is a main kilowatt hour totalized value, it's an ever increasing value. In the web chart, we have the option to toggle delta values here. In that case, the web chart will display the change in value between each of the history records instead of the totalized value. We can see the same thing looking at the AX history table. We can see that the values here are ever increasing values. And if I toggle the delta icon now, the table will display the change in value between those totalized values for each record. When we're querying the histories with BQL, then this is just a BQL statement or ord. And we can see that the base ord is history and the main KWH totalized history. We are using the projection to display the timestamp and value, and the predicate is filtering the timestamps to be in BQL time yesterday. And we can see that the values are increasing, totalized. I want to see the interval values in this result, then I put the question mark delta equals true syntax in my BQL ord. And now the engine returns the interval values then between those history records. Right. It's also oftentimes necessary to chain BQL queries together. And what I mean by this is you can have a BQL query that is resolved and then a pipe symbol and a subsequent BQL query. So the results of the first query are piped into the second query. And that allows us, in some cases, to better format the information. A very good example of that is using the history rollup function. The history rollup function returns a specific schema with the timestamp, end timestamp, count, min, max, average, and sum aggregate functions all being returned. And maybe that's not exactly how we want to display the information. If we take a look at a query that's using, let's look at this. I'll just look at this one, I guess. All right, so in this case, this is a history roll-up query. Take a look at the BQL ord here. The base ord's history, looking at main KW, and I'm using the period syntax to limit that to last week. Remember, if you're using the history rollup function, you can't specify the timestamp limits in the predicate, so you need to use the period function. We're doing the history rollup function and passing in a daily interval. So in this case, my schema includes the timestamp, the end timestamp, which are both BABS time values, and then the count, min, max, average, and sum. If this isn't exactly what I want to see returned, this is a case where we can pipe this into a different subsequent query to specify the projection. So our initial schema being piped into the second query is timestamp, end timestamp, min, max, average, count, and sum. So you can see the first BQL query is here, and that is the history rollup function, and it returns the timestamp, end timestamp, count, min, max, average, sum. The second BQL query then is piped in with a pipe symbol, and then the projection is just referencing information columns which exist in the schema that's being passed in. In this case, the timestamp is a BABS time value, and I'm calling the toDate string function on it to just display the date. Maybe I'm not concerned about showing the 12 a.m. time as the first record. I just want to show the date. We can also reference the same column, again in this case, timestamp, but call the getWeekday function on it to display the day of the week. Then I'm also including the count, min, max, and average columns from the original schema because those all seem relevant to a KW power reading. But the sum of all the readings doesn't seem very relevant, so I'm not including that in the projection, so we mask that out of the results. And the last thing we really want to talk about here is the fact that escape characters might be used in the names of things. And if you do have components that have special characters in the actual name, Workbench encodes those using ASCII hex values to specify those characters that can't be actually used in the name. So Java has restrictions on what characters can be used. And if you use a dash character, a forward slash, a space, things of that nature, you're going to end up with these ASCII hex escape character sequences, like in this case, $20 is a space character representation. And $24 is the hex escape sequence for a $sign character. So sometimes in BQL, you'll have to utilize a $24 to actually escape the $sign character. The BQL engine will unescape that string when it's being processed, and it'll then yield a $20, which is really what we're looking for in this case. So take a look at that real quickly here. Let's show name without the escape characters. So I'm going to look at this ORD, and we're seeing that there's no results being returned here. So we're looking under this escape characters folder for a numeric point where the name is room $20 temp, and we see there's no results being returned here. If I look at the slot sheet of this folder, I'll see that the name of that point is indeed room $20 temp, but we're still not seeing the results here. And again, the reason for that is the BQL engine will unescape this text, and it will essentially return room space temp and unescapes this $20 sequence here. So in order to deal with this, we actually need to put a $24 and then 20. So when it unescapes the string, it'll convert the $24 to a $sign character, and then the predicate will actually test for the slot name, in this case being room $20 temp, and we should get results there. If you ever have a question about those escape code sequences, although I think most people know what they are, you can look at an ASCII hex table. I usually use this one on rapid tables as an easy one to look at, but you'll see, for example, for a $sign character here, the hex value is 24, or a space character, it's going to be 20 is the hex code. Common ones, a dash character, 2D, or /2F, for example. So within Niagara, then it's going to be a $sign and the hex value for whatever that ASCII character is. I hope you guys have enjoyed these videos on BQL and learned everything about the select statement, all the different clauses, keywords, and things that you can use to help with the performance and be able to query exactly what you need to and display the information that you need to in your projections. So stay tuned for more future videos on Niagara Pro tips, and have a great day.